All right, so we got oxidation by acid here of metals. So here you would have your metal, and then you've got your acid, and then the cation from the metal is going to come over here, and the H2 is going to be left behind from the acid. So this is what that would look like in kind of real terms, where you would have a metal. It would get reacted with some sort of acid. The hydrogen gas is going to come off, and you're going to be left with zinc bromide. And then we're going to learn later on, I believe it's in Unit 8, we're going to learn about if this is going to create an acidic solution or not, and how we can tell, or a basic solution, and how we can tell. And there's ways. It's either 7 or 8. I can't remember which one it's in. All right, we can have oxidation of metals by salts. So here you've got a metal, here you've got a metal with an anion, and they swap partners. So we talked about this. We would talk about this in terms of like an activity series. And back in the day when I taught you this, I talked about like a football roster. And if this metal is more active or a better metal than this one is, it's higher up on the activity series, then it's going to sub in. And then the worse metal is going to sit on the bench. Do you remember that analogy that I used with you guys back in the day? Okay. Yeah, so this is like Allie, and L's in the game, okay? And Allie obviously is a better player than L. Okay. And so Allie's going to get in the game here. She's higher up on the activity series or the roster, and L's going to go sit on the bench. So, you know, yeah, exactly. Yeah. You know, cuz L's maybe a D1 basketball player, but Allie is like WNBA material. So, you know. All right. We can have oxidation of metals by acids. So here, this is going from a +3. I'm sorry, not a +3. This would be a 0. It's by itself. This is going from a 0 to a +3 over here. So it's getting oxidized because it is losing electrons. Here, your hydrogen is going from a +1 to a 0. It's gaining electrons, so it's being reduced. So that's how you oxidize metals with acids. Oxidation of metals by salts. So here, this is a 0. Over here, it's going to be a +2. So it's lost electrons. Here, this is a +2, and this is going to be a 0. So it will have gained those electrons. So it will have been reduced. All right. So we are to assign oxidation numbers to the following elements. Well, this is a -2, so this has to be a +4. This is your I do? Huh. All right, well, we're going to do it anyway. This is a -1, so this has to be a +6. This is a -2, so this has to be a +5. Okay. Identify the elements that are being oxidized and reduced. Well, this guy is going from a 0 to a +3, so it has lost electrons. So the aluminum is being oxidized. And I is going from a 0 to a -1, so it is being reduced. Okay. All right. This should not be the end of my notes. You have more notes in your packet? But I have to go through balancing these things with you. Is that 4.9a notes? I don't think this will let me write on it.
Oh yeah, but the later you started in the earlier. Libby, I'm telling you, just go through like 2 or 3 of these. Make sure we got them down.
What?
Where's
Here's all I have to say. Book sucks. No one understood. I mean, let's be honest with ourselves. They always had to explain what it meant. So obviously. So how? And then the whole like essay, the whole essay was boring. Like they couldn't have picked more boring topics.
Tell me feminism is boring.
Esther Bryn is not a feminist.
I didn't say she was a feminist. I said
Well, then how are you supposed to write?
but now they'll
feminist?
explain it.
No, it did not. No, it did not. I did mine on like.
Oh yeah, like yeah.
I'm not saying mine's the same, but mine actually is presented as like feminism was not.
No, I talked about the difference in roles based on Mr. Brand and Reverend Dimsdale, even though they share the same city.
That's what I.
Which is
That's what I
different.
do.
Yeah. Which is a difference in inequality, which is.
All right, I at least want to talk about this. So find some scratch paper, flip over that something that we can. I want to do this problem right here with you guys. So write that somewhere. This. You have this in your notes? That's why I asked you guys if you guys had this somewhere. Okay. Well, give yourself room because you're going to need to write some stuff. Okay, you guys ready? So first of all, you check to see if the thing's balanced. Then you figure out what's being oxidized and reduced. Okay. So this is going from a 0 here to a +2 on this side. Do you need me, honey? Oh, okay. This is going from a +2 to a 0. Okay. The Cl is not involved at all. It is staying as a -1, so nothing's changing there. Okay. So now we're going to look and see what is changing or what's happening here. Okay. My magnesium is going from a 0 to a +2. So what's happened to it? So it's been oxidized. Now, generally speaking, that's what I start with when I'm working on these oxidation questions. Okay. So Mg yields Mg 2 plus what? What did it give off to become 2 plus? 2 electrons. Okay. Now, when we look at the iron down here, it went from an Fe plus 2 to an Fe. So we have to add 2 electrons to get it to happen here. Okay? Okay. Now, these electrons end up canceling out. And if we look at the net overall equation, then it's going to be Mg plus Fe plus 2 yields Mg plus 2 plus Fe. There's no chlorine involved. Now, here's the deal. If this did not match up electron for electron, like if there was a 3 here and a 2 here, you have to multiply through by coefficients to get those electrons to match up. Okay, and that's what I'm looking for here to see if I can find a sample that I can make that happen with. It did. Well, I don't know about your homework problem, but I mean, one of the questions that we had earlier, like yesterday, we had that happen. I think, yeah, it's going to happen here. Here we go. So if we look at this guy here, okay, zinc plus HCl. Let's do that. Zinc plus HCl. Let me find a bigger place to write on. So zinc plus HCl. Just ignore what's up here. I'm just finding a blank slide to be able to work with here. Is going to give me H2. No, that's not going to work. Cripes. Plus CnCl2. Yeah, that will that? No, that's not going to work out. Shoot. Ah, okay. Here we go. This guy will work for us. All right, so we've got, no, this is just another practice problem. I want to go through this. Al plus HBr yields 3H2 plus AlBr3. I think this one will work out for us. Show you what I want to show you. This is going from a 0 to a plus 3. And the H is going from a plus 1 to a 0. Nope, that doesn't balance, does it? Six. And I need 6 of these, so I need to put a 2 here, which means I need to put a 2 here. All right, is that balanced now? I think so. I would love you to take a study hall and be my service aid, lab aid, set up labs like Austin does. Yes, yes. I get 2. I don't have a service aid 8th hour. He's a virtual student who just hangs out here because he's got to take his brother home.
Hey, Jaden, why are you skipping class? I'm not skipping anymore.
All right, so my aluminum is going from here. It's going to Al plus 3, plus it's given off 3 electrons, yes? Everybody cool with that? All right, my hydrogen then is going to pick up. It's coming over here. Oh, does it pick up 2 electrons or 1?
Yes, we can multiply the bottom by 2. Excuse me.
No, that's not going to work, will it? It's just going to be H. But no, that doesn't work.
I think shouldn't it be 2H plus 2E goes like H2? So you should multiply the whole. I don't know. Yeah. It's found two there. You guys go over the board?
Yeah. Well, we're given
That
this.
works out.
Okay. All right. So now we have to get these electrons to balance. Okay. So the way we do that is we're going to multiply this by what? What's the common multiple between these? So we're going to multiply this by 2, and we're going to multiply all of this by 3. So this is then going to be 2Al yields Al plus 3 plus 6 electrons. And then on this side, we're going to have 6H plus 6 electrons yields 3H2. So then these electrons cancel out, and then you're left with the equation. This is your net ionic then. So 2Al plus 6H plus yields 2Al 3 plus 3H2. Okay, so that's what I wanted to go through. That's the final part of the notes for this. Now, I have some notes or some stuff that I want to talk about in terms of burettes. I don't think that we've used burettes yet this year, have we? Okay. So I want to talk about how we measure using burettes. Okay, because it's a little, and you've looked at these a little bit when you were looking at some of the homework a few days ago. I think it may have been like 4-6. Okay, so when you look at burettes, when you look at a burette, okay, make sure, ladies, make sure that you are eye level with it. And that might involve you climbing up on a stool to be able to get eye level, because these things are like that tall. Okay. So you may have to get up there to be able to see it. So make sure you're eye level. Now, this is the issue. These count backwards. 0 is at the top, which is not what you're used to. 50 is at the bottom. So this is 19. This is 19.1, 19.2, 19.3, 19.4, 19.5. You can be partway in between. So let's say that you're right here. That would be 19.05. You read it at the bottom of the meniscus, where you are eye level with the bottom of the meniscus. That's where it's read. So you've got some practice leading up into this for those things. Now, at the end here, we talked about net ionics earlier, but we haven't really talked about them since we've done the redox reactions. And that's why I wanted to give you a minute or two, or give you that flow chart. So I gave you this flow chart today to kind of take you through some of those different situations where you've got to write, ionic equations, and where you've got to write net ionics and that sort of things. It tells you when you're going to split things up. So hopefully that'll help you a little bit You can go through and write in like where you've got a strong acid or where you've got a strong base, what those strong acids and bases are, because you're still in the process of memorizing those. So this flow chart is for you to keep and hopefully help you out a little bit to be able to assist you with some of that stuff. So today, top priority for homework tonight is the progress check. Okay. No, you don't have anything else. So you've got progress check. Well, you've got 4.9, whatever's left of 4.9, and then the progress check. But the progress check is the most important of all of that stuff. So if you must prioritize, that is the so your progress check is your top priority. Somebody left when they came in to do corrections one day. Somebody left their progress check in here. It's up there on the board on that paper, the pink clip up there. So if you're missing a progress check, that is probably yours. No, it was not in your packet. I neglected to put it in your packet. I ran it off separately. So if you need one, that's the one that was left in here. Okay.
Maybe it was mine. Yep.
It is in our packet.
It is?
Yeah, it was
Oh.
in the progress section.
Okay.